Well, when you've already automated, deleting must be real painful.
Yeah,
See, you've
yeah,
gone
it's
through
very.
all of
It's
it.
like wow, I really wasted a lot of effort there.
Yeah. I mean, what you've done with the cluster in Memphis is incredible. Just in a handful of
Well,
weeks.
yeah, it's not working yet, so I don't want to pop the champagne corks. Um, in fact, I have a call in a few hours with the Memphis team because we're having some power fluctuation issues. Um, so
Yes.
yeah, it's like kind of there's a when you do synchronized training, when you've all these computers that are training where the training is synchronized to the sort of millisecond level, you it's like having an orchestra, and then the orchestra can go loud to silent very quickly, at sub-second level. And then the electrical system kind of freaks out about that. Like if you suddenly see giant shifts, 10, 20 megawatts several times a second, this is not what electrical systems are expecting to see.
So that's one of the main things you have to figure out: the cooling, the power,
Yeah.
and then on the software as you go up the stack, how to do
Yeah.
the distributed compute, all of that, all
Yeah.
of that has to be working.
Today's problem is dealing with extreme power jitter.
Power jitter.
Yeah.
There's a nice ring to that. So that's okay. And you stayed up late into the night, as you often do there
Last week. Yeah.
last week. Yeah.
Yeah. We finally got training going at oddly enough roughly 4:20 a.m. Last Monday.
Total coincidence.
Yeah, I mean maybe it was 4:22 or something.
Yeah,
But,
yeah.
yeah,
It's that universe again with the
I mean
jokes.
exactly. Just love it.
I mean, I wonder if you could speak to the fact that one of the things that you did when I was there is you went through all the steps of what everybody's doing just to
Yeah,
get a sense that you yourself understand it and everybody understands it so they can understand when something is dumb or something is inefficient or that kind of
yeah,
stuff. Can you speak to that?
yeah. So I try to do whatever the people at the front lines are doing. I try to do it at least a few times myself. So connecting fiber optic cables, diagnosing a faulty connection. That tends to be the limiting factor for large training clusters is the cabling. There's so many cables. Because for a coherent training system where you've got RDMA, sort of remote direct memory access, the whole thing is like one giant brain. So it's you've got any to any connection. So it's the any GPU can talk to any GPU out of 100,000. That is a crazy cable layout.
It looks pretty cool.
Yeah,
It's like the human brain, but like at a scale that humans can visibly see. And it is a cool
yeah.
brain.
I mean, the human brain also has a massive amount of the brain tissue is the cables.
Yeah.
So they get the gray matter, which is the compute, and then the white matter, which is cables. A big percentage of your brain is just cables.
That's what it felt like walking around in the supercomputer center. It's like we're walking around inside a brain that
Yeah.
will one day build a super intelligent system. Do you think
Yeah.
do you think there's a chance that XAI that you are the one that builds AGI?
It's possible. What do you define as AGI?
I think humans will never acknowledge that AGI has been
Just
built.
keep moving the goalposts.
Yeah. So I think there's already superhuman capabilities that are available in AI systems.
Oh yeah.
I think what AGI is when it's smarter than the collective intelligence of the entire human species.
Well, I think
Inarguably.
that generally people would call that sort of ASI, artificial superintelligence. But there are these thresholds where you could say at some point the AI is smarter than any single human, and then you got 8 billion humans. So and actually each human is machine augmented by the computers.